Hello, hello. Okay, there we go. The rumors are true. We're doing Unity meshes. I am gonna be honest. They scare me, as they should, probably. But this is to do a single quad. One quad. Two triangles. And it works, but I need a lot more than two. So if we look at this mesh, it has two triangles, it has four vertices, and all the UVs are set. I have it set to this material. It works, it functions. That's awesome. I need to figure out a way to make a lot of these triangles, and then dynamically change the position of the vertices based on where I click. The first hurdle to overcome is getting a bunch of vertices. So I need to make a bunch of vertices, first of all. Where's paint? In the way of it. I'm thinking that we just have, like, a giant grid. I did not check blend shapes, but I don't think that that would help me. This is, like, very specific. I'll look up blend shapes, though. We'll check it out in a second, but I need, like, a giant grid of these. And generally, so you can do vertice assignment in a couple of ways. You can either really do it clockwise or counterclockwise, so it would be like, this is vert 0, this is vert 1, 2, 3, 4... Oh, I actually don't know. It's very confusing, I'm gonna be honest. Because you have to set it per triangle, and I'm not exactly sure which vertice index is which. I'm pretty sure I'm setting it here, so it would be... If I wanted something like this, then it would be... Yeah, I'm setting it there, so it would be 1, 2, 3, 4, 5, 6, 7, 8, 9 vertices. So let's try that. I want to look at blend shapes real quick. That's a blend shape unity. I have no idea what these are. I'm presuming it's basically just lerping between two, like, meshes. Which seems awesome, but I can use later, but I can't really use it right now, I don't think. So yes, skin mesh, we have a mesh, a blend 1, blend 2, blend speed, okay. What does this even mean? I need to know what the skin shape, or the skinned mesh actually means. But yeah, we're gonna be doing a lot of reading articles and experimenting with Unity, so today's stream is gonna be a little bit slower than most. Warning well in advance. And a lot more technical than most. Because I don't really know what I'm doing, but we're gonna figure it out. Okay. 0, blend 1. What does this do? Skinned mesh render component. Is this different than a mesh render? Okay, yeah. A video would probably help me. This is in Maya. Okay, this is in Unity. Awesome. Okay. This is exactly what I thought it was. I don't know how to implement it, but I don't think that I need to. Horizontal slider, cool, skinned mesh renderer. Where are they setting all the meshes? That's my biggest question, honestly. Where are all these meshes getting set? Mesh body. Or not the meshes, where are these blend shapes getting set? Because I couldn't find that in the documentation. Okay. Let's look at this real quick. So it imports the blend shapes. Oh, with the skin mesh render, all of these blend shapes have their own variable. So the eye blink, the snarl, the sad, and the happy were blend shapes that he made in Maya, which you can also make in Blender. It's the same thing. And then he imported it into Unity, and it automatically imported that. Okay, cool. I can't really use that yet. I don't think I can ever use that, actually. But it's definitely interesting. I can't use it for this project. Well, not in this specific instance, but something that I probably should look into later. God. So, I'm gonna read this article real quick. Wait, maybe I'm gonna skim this one to see if it's even remotely useful. Setting up basic scene. No, not right now. This seems like a more useful article. Yeah, I can't use that right now, but definitely seems interesting. Okay, so constructing a triangle. Component of, yeah, okay, whatever. Unenable. I should probably actually set the name of this. Which I definitely can. No. Actually, I can just set the name later. I can just do this. Mesh.name. Test. Mesh. It doesn't really matter that it has a name, but makes me feel better about it. Look at that. Nice. Okay. Cool. We have a name. Progress. Okay. So yeah, it's always read and write enabled. I don't know why they're even explaining that. So I need to add vertices, and the way that this works is kind of weird. So you have to set all of the vertices and the triangles. So right here I'm setting all the vertices, and this is in world space. So 0, 0, that's 0, 0 in local space to the object. So the object is currently at 0, 0, so this position, or this is getting placed at the center of the object. This is getting placed 1 above the object, because it's a vector 3, but it's x, y. So 1 unit above, this vertex is getting placed. 1 unit above and to the right, this vertex is getting placed. And then 1 unit to the right, this vertex is getting placed. The UV, so UV coordinates are different than world coordinates. UV coordinates are always from 0 to 1. And it's per texture. So, where's paint? So let's say that I had like this texture right here. It's a box and has like a smiley face on it. If I wanted this mesh right here that has 9 vertices to entirely display this through the entire thing, then I would need to basically treat the UV coordinate space as the entire box. This is 1, 1, or this is 1, 1, this is 1, 0, 0, 0, and 0, 1. Again, just think of like a grid. We're talking about 2D space right now. The UV coordinate space is 2D. So we have a box on this grid. Think of math. Back in your math class, this is the box, okay? If I made it to where this vertice was this. This vertice was right here. This vertice was right here. So this would be 0.51. This would be 0.5, 0.5. And this is, I'm setting in the UV coordinate space where this index is, or where this vertice is. And this is all based off of the index of the vertice. So I'm setting the first index, which is 0. In the array, I'm setting that to the bottom left, which is, again, 0, 0 in world space. This UV0, it corresponds to the first vertice. This triangle 0 is the first index in the triangle. So for my first triangle, which is 0, 1, and 2, I'm setting it to vertice index 0, vertice index 1, and vertice index 2. For the second one, I'm setting it to 0, 2, 3, which I can explain that real quick. Basically, we have okay, so we have a vertice here, which this is 0. This is the index 0 at 0, 0. This is index 1 at 0, 1. This is index 2 at 1, 1. And then this is index 3 at 1, 0. So the first triangle, this one, the top one, I'm just going to mark them, X and Y. So the first triangle, triangle X, is made up of vertices 0, 1, and 2. Triangle Y is made up of 0, 2, and 3. And you usually want to do this either clockwise, so going that way, or counterclockwise, going that way. I did it clockwise. It doesn't particularly matter, but you either want to do it clockwise or counterclockwise, otherwise you run into some weird problems where it's just going to be really hard to keep track of what you're doing. So that's why it's 0, 2, and 3, and not like 1, 2, 3 again. And then this is the first triangle, this is the second triangle. If I set this to like 1, for instance, this is going to break everything immediately. So this is going to look real weird. Yeah, look at that. Because what this is doing, we go back over here, it's going 0, 1, 3, and then 0, 1, 0, 1, 2, and then 0, 1, 3. So we have 2 triangles like this, to where they're overlapping and then there's nothing here. So we get this shape. So we can back out of that. So I understand how to make the mesh. Like, fundamentally how it works. Not exactly sure how to make that really tileable, and then I'm also gonna have to figure out a way, because what is nice is the vertices are in world space. And that's something, it's local world space, but I can calculate the mouse's position in like the relative position of it from the mesh really easily. Because the origin of the mesh is at 0, 0, so it's this equals world, like global world space, if I don't move the mesh. If it's 0, 0, it's fine. I can loop over them, yes. I could make a giant grid, and then I'm gonna have to figure out actually how to make that loop. And I could also, whenever I'm trying to figure out a way to do this without destroying my PC. Because if a loop gets too complex, it gets real messy real quick. You know this. Darth, you probably know this a lot better than I do, but... So I was in class yesterday, and my computer science professor explained some, like, basics of Big O notation. It's a very early class. I I'm trying to get a computer science degree, so I had to take it. But he made a very inefficient Fibonacci sequence finder, to where you can find like the nth Fibonacci number. And he set it to 34. It took like 5 minutes to do it. And then he set it to 100. And he was like, the heat death of the universe will happen before this finishes. And that just, it's deeply hilarious. If you mess up recursion, or make it too inefficient, or make a loop too inefficient, everything dies. And I love that. I love that so much. Think O notation in general is just very funny to me. Because if you mess up, it's just over. It's over for you, man. You're never... It's never getting done. It will literally never get done. I'm pretty sure the program was 2 to the n big O notation. This is why you use LinkQ. What? Okay. Isn't LinkQ for functional programming in C#? Isn't that what that library does? To my knowledge, it's what it does. I'm actually not 100% sure, though. Okay, so... let's try to make... I'm gonna try to make a loop, like you were saying, to make n quads. So this would be like... This is a 2x2, right? This is a 2x2 quad. And it doesn't really matter how I deal with the UV space. It just needs to be set. Like, I can just set all of the UVs to this because I'm just using a blank texture. The tiling doesn't matter. It's just white. And I'm going to keep it white, and I'm not going to mess with the textures right now. If I really want to, I can do that way far down the line. But yeah, I'm going to make a loop real quick. By real quick, I mean, probably going to take a while. Actually, I don't know how to do this, but we're just going to try to make a bunch of quads. We'll figure that out. And then we can move on to moving things. Come on. It's not PTSD, okay? You have Stockholm Syndrome. It's different. You still like Overwatch. I see you in damn custom game lobbies. Still coaching. You like meshes? You see, I'm hoping that I will also like meshes by the end of this, but right now they terrify me. You're a player, actually? You're still playing competitive Overwatch? Nerd. Q helps with looping logic? Okay. Wait. Let me open this. Let's read this article. No, I'm not really into game development. Lol. Okay. You're about to win the Rainbow Open? I don't know what that is. I am not using OpenTK. Yeah, I'm using Unity. Right here. Yeah, I pretty much used Unity for a while. I like Unity. I want to learn other game engines, but they scare me. And OpenTK sounds like... It may not be a game engine. It sounds like a framework. And that's doubly scary. Okay, so... Get nearest game object. Gets a list of game objects. And then game objects consider. Smallest distance equals method.unity. Okay, infinity. Nearest game object. Okay, so they're just initializing this to a super far distance, and then we're going to check for the nearest object, which is doing vector 3 distance. Okay, awesome. Scenario 1 would find the... Okay, LinkQ version. Okay, I hate this formatting, but yeah. So, order by t lambda vector 3 dot distance transform dot position t transform dot position. So this is just for every single t, find this and then order it to where it is either largest to smallest or smallest to largest, and then find the first in that list, so it'd be smallest to largest, and then find the first in that list, and then return that as nearest. I'm pretty sure. Because, yeah, we have a list, so check everything in the list, order it properly, and then find the first one. If you watch OpenGL, 3D voids scare you? What the hell's a 3D void? 3D void. OpenGL. No, not void. What is this? What are you? No, I want to be able to see it. Okay, wait. Okay. Oh, these are voids. Like flock simulations and stuff. Yeah, voids in general just seem very complicated to me. I want to learn how to do them. They seem like a really interesting... Like, I'm not sure how useful they would be, but I feel like I can slot them in at some point into some game and just use that as an excuse to learn how they work. Because I really like programming. Like, genuinely, I really enjoy it. So I like finding excuses to learn things that I probably don't need. Yeah, that sounds scary, especially in OpenGL. Damn, man. It's like Noid from Domino's? Okay, alright, man. Rendering a million objects that only one of them... Okay. And each one of them have some logic, and it runs insanely fast. How does it run insanely fast, though? There has to be some crazy, like, optimization that makes that possible. Because I feel like we've been doing voids for a very long time. Like, processing power right now, you can get away with a lot of mistakes, but I feel like we've been doing that for so long that there has to be some crazy way that people are doing it. I'm not going to pretend I know anything enough to even comment on that, but... Algorithm and data structure with computer shaders, or with compute shaders. Dude, compute shaders, like, when I look into the history of graphics programming, compute shaders are insane. Like, being able to write directly to the GPU and stuff, it really seems like that was a, like, really, really, really big innovation. Okay. You're trying to learn OpenTK and you're still going? What is OpenTK? OpenTK is a set of fast, portable, low-level C# bindings for OpenGL, OpenGL-ES. Okay. Runs on all major platforms, powers hundreds of apps, games, and scientific research programs. OpenTK provides several utility libraries, including math/linear algebra package, a windowing system, and input handling. It's not a game engine, nor does it try to be one. It offers a useful set of tools and lets you decide how to use them. It is the ideal starting point if you want to write a game or specific application from the ground up. Okay, so it's like a library. It's a library that deals with linear algebra, math, windowing system, or windows like this, and input handling. Nice. Check the tutorial. Tutorial. Where are you? Learn OpenTK. Okay, OpenGL scares the hell out of me. Why is this all OpenGL? Well, I guess it is an interface for OpenGL, it sounds like. OpenGL itself is a large state machine, a collection of variables to define how OpenGL should currently operate. The state of OpenGL is commonly referred to as the OpenGL context. When using OpenGL, we often change its state by setting some options, manipulating some buffers, and render using the current context. Okay. Whenever we tell OpenGL that we want to draw lines instead of... Okay, I saw the word state machine and my mind immediately fired because I was like, AI! Game AI! What, you mean learn? Okay, no, we're here. We're here. I don't think it would work with OpenAI. That is not OpenGL. OpenAI is a completely different company. This is a graphics library. Okay. Understand how OpenGL works. Creating window. Hello Triangle. Banger name. It's a fragment shader. Oh, okay. That makes sense. Alright. Any graphics programmers out there? I'm about to trigger the actual hell out of you. Fragment shaders. Hey, guys. Listen to me, okay? Get real close. Fragment shaders are just pixel shaders. You're just doing it by pixel. I know, I'm sorry. I'm sorry I had to tell you it this way. I'm sorry that every single graphics programmer is incredibly delusional and doesn't think that a fragment shader... that refuses to acknowledge that a fragment shader is just per pixel. People are saying OpenGL is going to be replaced by Vulkan. Isn't it mostly already replaced? I feel like everyone that I talk to uses... like, if they're trying to make something that... A lot of people in the industry use Vulkan. That's what I'm saying. A lot of people in the industry use Vulkan. A lot of people that are not working in a professional aspect use OpenGL. That's what I've seen. I don't feel like... Vulkan seems to be a lot... maybe not not more complicated, but more... There's more overhead with Vulkan, it seems. Yeah, it's bulky and a lot of code to generate even a triangle on the screen. So I feel like for beginners, a lot of people just use OpenGL. And like, a couple of my really close friends are working on a graphic, or not a graphics engine, they're working on a game engine. It's coming along like really nicely. It's very impressive. And they're using OpenGL. I mean, it's great. Like, it works good for them. I don't think there's anything wrong with OpenGL. I don't really know enough to super comment on it, but... Got temp banned from my Discord for talking about Mug because he said the F word. Get destroyed. That is literally... Okay, wait. Let me look at my moderator logs. Every single log on the mod logs is someone saying the F word. Every single one. Carlbot has been putting in the work, alright? I think it's deeply hilarious. It's a lot of code to maintain. All of them are building voxel engines these days. Okay. Like, voxel engines are cool. However, I don't feel like we need another voxel engine, okay? We have a lot. There are a lot of voxel engines now, which is cool. It's a neat way to do it. Minecraft is insane. Like, the code structure for Minecraft is really cool. All the YouTubers? Okay, but I feel like that's just because... What is your problem with voxels, Cement? Alright, voxels are fantastic. But yeah, no, I feel like it's because the way that Minecraft does voxels is really, like, clever, and programmers want to, like, have an excuse to emulate that. Because the way that it does culling is really clever. I don't fully understand how it works, but only the things that are that you see are rendered, because it does occlusion calling, but it's occlusion calling per face, which is insane. Because there are so many, like, just look at a Minecraft map, every single block, that's a quad on each side. So you just switch 6 quads per block, and 3D voxel cellular automata, or automata, under raycast look awesome, but you have to sell your blood to a demon to build that side project? Okay, 3D voxel cellular automata? Trying to... Okay, yeah, so that would be like... You're talking about, like, caves and stuff. Like, cave generation? Yeah, it is a lot of work. On one of my old projects, I saw it on YouTube. Yeah, They're again, the way that like Minecraft uses that kind of will the roughly you can emulate Minecraft kind of using cellular automata. That stuff is insane. That stuff is so cool though. But the way that so I was working with a few friends on a project a little while back, and we wanted to make caves using cellular automata and even just 2D. It was a 2D game. That was difficult. That was like surprisingly difficult. Like procedural generation in general is insane. And I love it. I love it though. It's so cool. It's so cool. But yeah, this seems really interesting. I'm not... What does OpenTK actually do for you? It seems that, like, you're interacting with OpenGL, so it gives you input window management and something else, right? Yeah, and math linear algebra package. It doesn't feel like it gives you that much, to be honest. That's interesting, though. Our program can make cool shit in ZBrush? Because you're making your cool shit move dynamically with video games. Are you doing more 3D art now, Sumet? Because I know that you've done a lot of that in the past. Dude, you should, if you're doing anything like that, send it to the Discord. I want to see it. We have a show off your work channel. I'd love to see it, man. Right here. Show off your work. People post a bunch of really cool stuff. By the way, Alan the Brush is actually a crazy person. He makes super cool stuff. Wait, can I link? Ah, I can't find it. It's in the chat though. His stuff is in the chat at some point, or in the show off your work channel. I seem to make links to everyone I find cool. You'll have a lot of low-level control of the API, so you can optimize the game if you want OpenGL. Yeah, Alan with a brush. In the brush. In the... What? It's in the brush. Okay. Drives me crazy because his... Or their... Twitch name is Owl in the Brush. Or it's Owl with the Brush. It's all over the place. But yeah, this is really cool. Chandu, do you have anything that, like, you've made? I'd love to see it, man. We have a Discord. You can send to the show off your work. Genuinely, though, I feel like... I really like to show off your work. Stuff. It keeps me motivated, because I see you guys making really cool stuff, and I'm like, I have to do that. I have to make cool stuff. We can all, like... we can sap motivation off of each other. Okay, back to what I was doing. Where were we? Thank you. Okay, what the hell is T Lambda? You started like 1 week to move to different stuff. You're doing it on the side and render 3D cube, light some textures on it. I'm a motivation vampire. But like, sending your stuff doesn't suck your motivation. It just gives it to other people. You get to show off your work. And then people are like, that's really cool. And then you get motivation because you're like, dang, people like my work. It's just like an infinite loop. Okay, so you'll see a lot in link queue statements. This is called lambda operator. In this case, operator by order statement, think of the T as a reference to each object in the collection when it orders them by distance, passing in our local object's position and the position of T. Does it have to be T? T is just a variable name. It could be easily as a thing to compare, or any variable name. T is just common standard, and lambda functions often refer to variables. I should look more into link queue. Okay, you're sending me real-time rendering resources. I actually have every single one of these books. Wait. Is it here? No! Cause oh no! All my bookmarks are gone. This is the worst. This is the worst. Okay, I need to bookmark this immediately. Wait, why is it all in other bookmarks? Whatever, I'll deal with that later. I had all of these books, or all of these websites, which is just a book. It's just a book. It literally is just a book. I had all of them saved, but all my bookmarks are gone. I have to turn on sync? Ugh. But then it'll actually... I don't want it to sync my bookmarks. That's the problem. It's annoying. I don't want it. Ooh, wait. I'm showing this. Darth's working on another project. The trees are moving. Interesting. Okay. Burly bullet hell action roguelike survivor idea about a lumberjack killing trees coming to life. Nice. Also, can I just say, Darth, I love that you always have a console for every single one of your prototypes. This is something I've noticed about every single one of your projects. You have a console that you print things to. I hate to break it to you, buddy. Unity has one. No, I'm just joking with you. I'd really like it, actually. I think it's really neat. Low poly Minecraft tree chaser. But yeah, keep sending stuff in. I want to see how that project goes. And if you ever have a playable build, send it to me. I'd love to test it. Okay, so back to link Q. Okay. What is first or default? First or default call makes our link Q statement return the first object from that collection, or whatever the object default value is. Default is just the value you'd have if you never assigned the value. That object's for null, or for objects that's null. It's also a first method, but they'll throw an exception if there's nothing in the collection. Okay, so it's first or default. It's a test to see if orthographic works. You saw a lot of games have in-game consoles, and also saw Red Cabin Games and Tomatoes sell it do that. Yeah, no, I think that having an in-game console is really good for debugging, especially in builds. And then if you have an in-game console that also allows you to like type commands in, then that's like really useful for a bunch of different things. I implemented something like that in Soulshot. It was like really rough though. If I learn LinkQ, if you learn LinkQ, then you think I am new to C#. Use use LinkQ pad. That way I can learn it fast. I wouldn't say that I'm okay. I would say I'm new to C#. I'm not new to using C#. I've been programming for like 8, 9, 10 years, 10 years now, I think. And I've been making games for like 8. And the only time I've ever used C# is in Unity. So that's why I have very, very like little knowledge of general C#. Because I basically only use it in Unity, and most of that you don't need like a crazy amount of knowledge, because Unity handles a lot of stuff for you. So, but I'm trying to learn more stuff. Like I'm learning C++. I took like a day to just experiment with Python. Python is really easy. I feel like anyone who knows programming can learn Python in a day or two. Python is like really simple, which is good. A lot of people use Python. See, use LinkQ pad to check C# language features fast. Okay, what is LinkQ pad? .NET Programmer's Playground. Interesting. Fantastic learning tool. What is this? Is this a debugging tool? Instantly test any C sharp, blah blah blah, Visual Basic, F sharp, snippet or program, query databases in LINQ or SQL. Okay. Enjoy rich output formatting, auto completion with AI, and integrated debugging. Script to automate your favorite .NET language. And automate in your favorite .NET language. Interpolate with XUnit, benchmark.net. Okay. Excel and more. Excel, my favorite database. Neat. Okay. I'm gonna... Doop. Wait. Nope. Oh, come on. Uncheck that. Go down. I always have a list of things. So this is called LinkQPad. LinkQPad. I will check that out in more detail later. Okay, so sorting by multiple things. You saw the order by method above, which is great for sorting, but sometimes you'll need to sort more than one thing. For example, imagine you have a scene full of dogs. You want to sort the dogs by color and size. Okay. Switching the order. I just need to look at the entirety of LinkQ, I feel like. LinkQ, C Sharp. Language integrated query. Can I just find the entire library? Is there can I just find the entire LinkQ documentation? Please? No? Why? I think I wrote some good C# books you can download in the editor and play with the language features. Thank you. Okay. Okay. I think my biggest problem with the Microsoft C# documentation in general is it does a lot of like gish galloping. It just keeps yapping and it doesn't stop. I just want to know what all of the functions are and what they do. I want something like this. Wait. Like sure, some examples, maybe? This is neat. I like this. Like just basic explanations. I feel like this is not giving me just a list of things. Okay, language query syntax. I mean, this is kind of the same thing. Maybe I'm mad. All right. I also have a little bit of. I had the horribly traumatic experience of reading through 4 different event systems, and to figure out that action delegates are actually the best way to do it. Horrible, horrible, horrible day. I learned about functional programming that day, ruined it. It just ruined C# for me. I'm joking. Mostly. Hate functional programming, though. Could never be a Rust dev. Okay. LinkQ experts. P programmers, where P is new to LinkQ. What? What is this? This is just the syntax. This isn't a real function. This is... Okay, good one. LinkQ is expressive. That is cool. What is RFID? Okay, wait. Pets 2 dictionary. Pet RFID. What does this even... How? Bar pets and pets. Pet RFID. Pet. Okay. This is just... It's weird. It's a prop of P? I don't know what that means. What do you mean it's a prop? Okay, filtered items. Items that where, okay, item that foo. Excuse me, sorry. I had to cough and I didn't want to destroy your eardrums. Okay. From item and items where... What? This isn't expressive. This is confusing. This is my problem with functional programming as a general paradigm. What is this? What is happening? Okay. Filtering list. German Shepherds. Dogs. Dot where. Where select aggregate. What the hell does that mean? Where dog? Okay. Where dog equals German Shepherd. Okay, cool. Query German Shepherds. From dog in dogs. Where dog breed equals German Shepherd. Select dog. So this finds all of the dogs? Maybe? All of the German Shepherds, I think? Cats? Select dog dot select dot turn into cat? Wherever I see where, for me, it's just a for loop with if logic in it. Okay. Sure, I can get my head around that. Okay, summing up lengths. Aggregate. What is seed? Seed is 0. Partial sum, next string. What is this variable? Where did this just come from? Okay, literally nowhere. They made it up. This is a tuple, I think. Right? No, what is this? I genuinely have no idea what's happening here. I love link Q. Love it. Love it. Love it. Okay. It's an anonymous function. Awesome. A non-anonymous method in C#. Okay. What? You have to start from delegate action type and then link Q. Okay, I understand how delegates work. Like, I get that. Delegates are so simple. They're very nice. I like delegates. I like actions. Delegate actions, fantastic, alright? Arithmetic operation. Okay, but now they're anonymous? Sure, lambda expression? What? Okay. So this is just... Okay, so this is the delegate? I think? Question mark? Wait, where was I? Yeah, we're right here. Okay, they just... Sure. Select many... Oh, man. Okay. So this is calling a function? Or this is calling a delegate and passing these in. I think? Oh, okay. Oh, that's cool. Input parameters expression. Yep. So it's basically... Okay, this is deeply cursed. I'm sorry. If this is... Oh, the gross. Disgusting. So it's saying... Here... where are you? Where... Okay. It's saying, make this function. We're doing a function. We're doing... It's an anonymous function with these parameters, and then we're going to use those parameters to... We're going to add partial sum plus the next string, and then we're going to go to the next one, and then add that again, and this is the aggregate of all of these operations. Yes. And this was a list of strings. So it's going to add all of them together. Some visualization. Okay. Okay, what's this other one? Bro. This... This is disrespectful. This is disrespectful. I'm sorry, okay? If you need to do this in order to... If this is the only way to understand something, maybe... It is a good visualization. I'm being pissy about it, okay? This is gross. I don't like this. I don't like that I have to... I just want a list. I want a list of all the functions. I mean, I guess I have it here. Thank you. What the heck, man? Functions when you want to return something... You want to return form the function action is where you don't want to return. Okay. Okay. To dictionary. Look up. Okay. To array. To list. Materialization conversion. Okay, sure. Merging, zip, join, filtering, where, take, while, skip. Okay. Of type, district by, or distinct by, grouping, group by, first, and there's also first or default. Well, for quantification, sequence contains, where's aggregate? Aggregation, aggregate, max, min, count, sum, intersect, union, except, select many. Okay. Okay. Interesting. Took you a good time to understand link queue. If I make my own link queue function from scratch, I would understand it. Probably... I'm gonna ignore link queue for the moment. It's something that will come with time. I have been exposed to link queue quite a few times, and every time it just scares me, and I learn a little bit more, and then I put it back on the shelf, and I'm like, I'll keep taking it out every little while and then put it back. But yeah, I'm gonna go back to trying to figure out the meshes, which could probably be done better with link queue. I fully admit that. But we're making a prototype right now. I just want to make the system work, and then we'll worry about optimization later. I'm just gonna make it work. Premature optimization is the root of all evil. That's my excuse. Okay. We're gonna read this. You don't know why I want to use link queue in game programming, but you're not a game dev. I don't know what ASP.NET is. Okay. I'm gonna download that, and then no longer touch link queue for a little bit. I'm gonna read this article about performance. Of course, with anything, and I'm gonna read this, and then we're gonna move on to moving with the meshes again. Okay. Of course, with anything, you'll need to consider performance of the operations like this. In the majority of cases, using link queue won't hurt you at all. It may add a couple of nanoseconds here and there, but you can also shave off time of your custom code. Yeah, okay, if your custom code isn't completely optimized, one thing you'll definitely need to do is look out for garbage collection. Link queue statements will generate a little bit of garbage, so avoid using them in something that's going to be called every frame. Don't put them in your update calls, fair enough. For other events, though, link queue can be a huge time saver. Make your code easier to read and have less code always reduces the chance for bugs. So link queue is not very optimized, it seems. Or it's not the most optimized way to do it, but it is probably more optimized than any way I would be doing it. Interesting, though. Deferred execution. This is what you did for, like, the giant tree that initialized every single manager script, right? It was deferred execution. To where it was like, only do this after this? Wait. Take this example. Coins by distance, all coins, order by, sure. Yield return null, vector 3 hasn't called once, everything's still deferred. Coin, do something. Okay, iteration makes link queue statement. Okay, by ordering the distance, the coin's only done by the player presses A, and even if it's not the delay we've passed for each. Oh, it's not until the delay is passed for each statement. If never reached, deferred call isn't needed, so it never runs. Okay. This iteration makes the link queue statement execute. Okay, it just does something, doesn't matter. So we order the coins, then we wait for a second, and then if the player is pressed A, then they do something with that. Okay. INumerable? This is an async. This is a async function house. Don't say INumerable here. We're an async function household, okay? Okay, the order by distance checking of coins is only done when the player presses A. What about the other syntax? It's important to note that there are two different types of link queue syntax. One of them is the one I've shown you so far, and the other one is a bit more like SQL. For Unity developers, I'd recommend starting or staying with the fluent syntax you see here and avoid the SQL one. I found developers who don't do much SQL work tend to get a bit more confused with the other syntax, and the confusion causes bugs. Cool. Okay, back to dynamic meshes. Okay. Dynamic mesh combining. I'm not going to touch that right now. So. How does this work? Well. Okay, so download the image, doesn't matter. Base map. Maybe not be, it might not be a bad idea to do this, but probably wouldn't be a bad idea to have an image that I can use for the base. Okay, let's just drag that in here.
Chandu16 just followed.
Hey, Chandu, thank you very much for the follow, man. Okay, let's go to the white material, and then we're going to actually give it a texture. And now that's properly tiled. And if we go in here, and then we set this to 0.5 F for all of, instead of it being 1, we set to 0.5 F for all of these. And then we're going to actually be in the middle here. as you see there. And if I set it to 0.25, then we're only going to have one square. It's going to be 0, 0. Cool, right? It's neat. Okay. Okay, so set those back. And then I need to figure out a way to make a bunch of these quads. Don't care about normal mapping. I'm gonna read this real quick. Constructing a quad. Meshes that contain more than a single triangle. Okay. To demonstrate this, or they can't contain more than a single triangle. To demonstrate this, we'll turn our mesh into a quad by adding a second triangle to it. We can create a quad by taking two right isosceles triangles and putting them together with their hypotenuses touching, which that literally just means this. This is the hypotenuse of the triangle, this bit right here. And it's just two triangles, like this, but touching, which is what we're going on right there. Okay, second triangle. We can create a quad by taking two right isosceles triangles, putting them together with their hypotenuses touching. We can keep our existing triangle and add a second one with its right corner at 1 unit from the origin, both the X and Y dimensions. We'll use the vertex origin. We'll use the vertex order right up 1. What does that mean? Why did they do it this way? Okay, they wanted two triangles completely separated. You can also increase the normals and tangents. Okay, why? What's even the point? What do the tangents really matter? I don't think that they matter in my context. Okay. Multi-stream approach. First positions, then normals, then tangents, then texture coordinates. Sure. Okay, so mesh.mesh array. Why are they doing it this way? This seems like a very complicated way to do this. Which approach is a simple AI mesh use? Single stream approach to where you... So this is just... You set all of the positions at once. You set all of the... So we're going to do basically this, but we're going to do it multiple times. And that's what we're going to do for our loop. Because we're setting these, and we need to just do this a lot. Basically. Okay. We're gonna set a public int, and that's going to be... We're gonna set a vector2 int. It's going to be quad dimensions. Or mesh dimensions. So if we set this to... Let's go 3 by 3. And then we're going to need... We're going to set the mesh, set its name. And then, so we have 4... Okay, I need to figure out a generalized way to do this. So we have... let me just get rid of literally everything. I can't? Okay, we're just gonna do one of these then. Do one of these. Why are you like this? No outline? There we go. Okay. So we need... So I'm going to swap over to the other cam real quick. I'm going to go to the tablet screen. Hello. Move this real quick. Okay, can you guys still hear me? Yes. Perfect. So, welcome. Welcome to the other side. You guys can see into the abyss just a little bit. So we need... I need to zoom in. Where's the zoom? There we go. So, that's it. This is our quad. Right? Wow, why is that not pressure sensitive? That's super weird. Whatever. Okay. So this is our quad. And then this has 4 vertices. Okay, this needs to be way smaller. No, come on. Way smaller. That. So we have these vertices right here. That's 4 vertices, and then if we want another quad, we're barring 2 of these vertices. So we only need to add 2 vertices, right? Yeah. And then we just connect it. And if we want to add another quad, we only need to add 2 vertices. So we're going 4. And then if we, but if we want to add a quad here, then we only need 1 more vertice. So we have 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, how can we make this? We need a generalized formula for how many, depending on the dimensions, how many vertices we need. Because we have to set the array size. So this would be an array size of 9. And then if we want to add another one, then we need to do 1, 2... Let's add like another dimension. So 1, 2, 3, 4, 5, 6, 7. So we needed to add 1, 2, 3, 4, 5 here. We'd add 1, 2, 3, 4, 5, 6, 7, and then this is going to be 9. So it's going to be 1, 2, 3, 4, 5, 6, 7, 8, 9. This is going to be 11. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So we have... So the basic formula for this is n. Let's write this out in sigma notation. So I equals 1. And it's going to be literally just the prime numbers. We're doing, or this is all the squares, sorry. In order to get the squares, so we need to get n squared, literally, that's it. N squared. This is 3 by 3, it's 9. This is 1, 2, 3, 4. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. This is literally, so if we want to do 1 quad, that's 2 squared, because it's 2 vertices. We want to do 2 quads, that's 9 vertices, that's 3 squared. So 3 quads is, so it's n plus 1 squared. Nice. pretty sure that's right. Which that, if we want to, because we have to add, no, we don't need to add this up, do we? No. So, yeah, this is all the vertices we need. This should hold true to everything. So let's do 1, 2, so 1, 2, 3, 4, 5. 5 vertices, or 5 quads. Y. Boop, 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 boop. Okay. So presuming that it's 5 wide, it's a square. This only works if it's a square. That's a problem. I need to figure out a way to make it work if it works if it's a rectangle. So we go up a little bit so you guys can actually see this properly. There we go. So if it's 5, then let's do this. So it's 5 plus 1 squared. We want 1, 2, 3, 4, 5. So this should be 6 squared, which equals 36. Does this actually hold true? 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30, 31, 32, 33, 34, 35, 36. It's true. Nice. So for a square, we can do that. We can. It's just n plus 1 squared. Now I need to figure out, because that's just length times height. So it's just, so we have our vector 2, which is the dimensions, and then it's just, we have our length and our width. No, yes, our length and our height, our width and our height. And this is just our width and our height. So this is just, yeah, the square, it's the same thing, which is just our width times our height, but this is plus 1, so it's actually width plus 1 times height plus 1. And now let's make another diagram here. So we want a quad here. Quad. Awesome. And let's say we want this to be 4 by 2. So we need 1, 2, 3, 4. Just gonna place all the vertices, and then we need 1, 2. Wait, boop, boop. Presume that these are all quads. Just bear with me. So if we have our formula here. So the vertices, so it's 1, 2, 3, 4 by 2. So it's, the width is 4. So it's 4 plus 1 times 2 plus 1. So that's going to equal 5 times 3, which is going to equal 15. Let's check. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. Wait, what? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. Okay. I somehow miscounted? That was silly. Whatever. This works. So this is the formula that we need for how many vertices we need. Awesome. Have the amount of vertices we need. Let's go back to the main screen real quick. It's probably a little bit hard to hear me. Let me move my mic back. Whoa. Hello. Okay. So, we're back. We're back in the land where my mic is close. And you guys can no longer peek into the abyss. I know it was scary, but don't worry, you're safe now. So, vertices, the amount of vertices that we need, it's going to be, again, it's going to be mesh dimensions. I'm just gonna actually rename this to dimensions dot x plus 1 times dimensions dot y plus 1. It's the amount of vertices we need. Awesome. UVs should always be the same as vertices. So we're going to just get int number of verts. That's going to equal this. And now we can just set number of verts in here. No. Bad. Number of verts. Okay. And number of triangles. Every quad is going to be... Every triangle is 3 in this array. And then every quad is going to be 6. So it just is width times height, I think. Let me bring this over here. So let's say, yeah, we want 8. It's just going to be, or this would be 4, 2, so it's 1, 2, 3, 4, 5, 6, 7, 8. So yeah, just width times height. It's easy enough. Awesome. Alright, so no, I don't need to do 8. This needs to be width times, no, not width, dimensions dot x times dimensions dot y. Awesome. Perfect. And now I need to actually set these to a value. Which, to do that, I can do a for loop. Which I need to go by quad. So we're going to set, this is going to be int I equals 0, which is going to be first index. I is less than... Okay, we're going to go up and then right. Yes. So it's going to be the first quad. And we're going to do the second quad, the third quad, the fourth quad. Let me get my glove off. Whoop. So this needs to be less than dimensions.y, I think. Dimensions.y. I plus plus. I'm actually just going to call this y. And we need another for loop in here. And this is going to be x. Int x equals 0. Well, x is less than dimensions.x. And x plus plus. So we need to set the first. We need to do this for literally all of them. Which is going to be... Okay, so if we think about a one-dimensional array, which it's just an array. If we think about an array, a flattened array, let's go back. We're going to the screen. Welcome to the screen world again. Okay, I'm gonna be quiet. Sorry. It's the way of the world. Wait, let me actually just turn this up a bit. Hello? 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 Okay. I'm louder now? That's good. Okay, so... Well, okay, we got our pen. So if we think about an array, so we have index like 0, 1, 2, 3, 4, 5, 6, 7. So we have 8 in here, right? And then we have 8 items. Let's say we want 2 quads, which we need to set 4 vertices per quad. No, okay, because we need to set that the position of this vertice, this vertice, this vertice, this vertice, this vertice, and this vertice. So we only need 6. Oh goodness. So we have an array size of 6. How do I do this? Because we're going first, we're starting at the bottom and then going up, right? Because we're doing this from Y to X, so we're starting from the bottom. So this is the first quad created. Just mark this out. So we have our first quad, and then we want to make our second quad. I'm just going to call this, yeah, so this is quad 1. And then this is quad 2. And then let's just make a 4x4 array. Or not a 4, yeah, we'll make 2x2 actually. Because we can extrapolate that. We know the pattern. If I can just draw a straight line, that'd be fantastic. So this is going to be created second. I think I'm actually going to change this color. Okay, I have to get rid of everything in order to get rid of that. Let's pick a color that will not blend into the white. It needs to be something dark, but not too dark. How about this? How about a red? We need a color because everything's blending and it's driving me bonkers. That doesn't work, but we'll go with it. Okay, so there's a hair on my pen and it's making it not glide. There we go. So let's just make our 2x2. So this is 2x2. 2 by 2. Awesome. Hey, how's it going? Let's do it. I'm doing a bunch of math, so fair warning, if math bores you, check in next time. I'm currently doing, trying to figure out how to create a dynamic mesh, but the first part of that is creating the mesh, and then I can deal with it dynamically. I'm trying to figure out how to just create a very large mesh of quads. One of these is a quad. This right here, that's a quad. This is a quad, that's a quad, that's a quad. We have a 2x2 grid of quads. Each quad has 2 triangles. And the first one created is this bottom left one. So we create this quad, then we create this one. And then we're done with this, so we're going to go down here, and then we're going to go here. So it's going to create 1, 2, 3, 4. This is going to be the first quad. This is, or this first triangle created. This can be this. Oh no. Okay. It's gonna get real complicated. This is gonna be index 1 or 0, 1. This is index 2. This is index 3. This is index 4. This is index 5. This is index 6. This is index 7. No, wait. This is index 6. This is index 7. This is index 8. That is horribly confusing. How can I do this in a way that is not as bad? Because if I'm creating these vertices...
Screw underscore it underscore let's underscore do underscore it redeem to say would you rather run a business Pikachu, or run a business with Sprigatito?
I don't know what Sprigatito is, I'm gonna be honest. Wait, let me look this up. Sprigatito. Okay. This... Would I rather run it with this Pokemon or Pikachu? What kind of business are we talking about? Okay. Are we talking about one possibly in the agricultural industry? Because I feel like if we're talking about agriculture, having a grass type, of course, would be, you know, a lot better. Personally, I feel like I would rather run a business with Pikachu. Alright, I'm gonna go out and say it. Doesn't... Wait, what does this Pokemon evolve into? What is their evolution? This one, okay. I feel like there's a very similar Pokemon, Fennekin. Wait, Fennekin? Fennekin. Yeah, this one. They also evolve into a standing thing. Wait, where is their evolution? Evolution. Where is evolution? Okay. Yeah. It just feels like a grass version of that. Electric Company with Pikachu, Farm Espargado. Yeah, exactly. Yeah, I'm making video games. Maybe if I was doing, like, electrical hardware, Pikachu would be useful, because he could power it. Can Pikachu power houses? He's just a battery, right? Pikachu seems way more useful than a grass-type Pokemon. Like, electric-type Pokemon, I feel like would be... Video games would be Porygon? Well, then I need a Porygon, alright? That's the answer. Okay, how do I make this not super confusing? Because what I would like to do is do like 1 or 0, 1, 2, 3, 4, 5, 6, 7. I missed one. No, I didn't. Okay. Like, this seems easier to me. This makes more sense. To where you go on the outside, you loop around the outside, and then you go in. So if we had, like, a larger mesh, to where it was like this... Wait, let me just make a giant grid here. Wait, that's not right. There we go. Okay, and... Bear with me while I just make a bunch of dots. How are you guys doing? How's your day going? Okay, there we go. I want it to be like... Yeah, all electric types could. Why don't they? Why aren't Pokemon houses? Because I feel like they wouldn't need to work that hard to charge the battery. Like, you just need a battery, and then it charges it, like, every day. You just have, like, a pet Pokemon, or a pet battery, a pet generator. Got out of work at 4? So better? You're hurting a lot, though? What do you do? Why are you hurting? Do you do, like, really physical labor? 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. And then you would move inside, so it'd be 21, 22, 23, 24, 25, 26, 27, 28, 28, 29, and this is just the index of each vertice. This would be 30, 31, and then you move in more because you're done with this loop. 32, 33, 34, 35. So that way, the closer that it is to the, like, the farther it is inside, the larger the index would be. You're Walmart setting up a truck. You're overweight, trying to improve that, but mess up your shoulder a bit, which doesn't help. You stock stuff for the entire store, usually. Yeah, that sounds like a lot of work, man. I just... One thing, and I feel like I've talked about this before. I feel like losing weight is very... Like, it seems to be very difficult. Gaining weight is very difficult for people that are, like, really skinny. Like, I have a super fast metabolism. I can't gain weight. It's literally not possible. But I feel like losing weight is really hard. Because it's harder to lose weight once you have weight. Because just doing anything is physically taxing. Like, you can't exercise for a long amount of time. Because you're just going to, like, you're carrying more. Like, even, like, jogging. You're carrying way more. Like, when I jog, I weigh, like, 127, 130 pounds. So, not much I really need to carry. And almost all of that is, like, my internal organs, water, skin, and muscle. Like, muscles, whenever I gain weight, it's just muscle. Or when you get an exercise bike or something like that. Yeah, honestly, I feel like... So we have a Planet Fitness up here in Alaska. It's so cheap. It's like $10 a month. I feel like that's worth it. Like $10, I feel like most people can spare that. The expense of $10 a month. Now you are like locked in for a year, which is insane. But as long as you're going consistently, like it's a very good deal. But yeah, we could do it this way. Which would be insane, because it would be, like, impossible to figure out. Or not this way. If we did it the way I wanted to originally, where it goes, like, 0, 1, 2, 3, and then we move up, and then we're like, oh, well, shucks, guess this is 4 now, and this is 6. This seems horrible. That would destroy me. Trying to figure out which vertice is which, although I don't know if it would matter. Let's try it. Yeah, let's just do it that way, and then we'll deal with the consequences. Which there will be consequences. But that's okay. Okay, we're back. I need to turn this down a little bit. Hello? Hello? Okay, there we go. There we go. Okay, I'm not destroying your guys' eardrums, I hope. Okay, there we go. You used to have a Planet Fitness membership until you guys got banned for your brother getting hurt due to a jackwad knocking him over and he had weights in his hands? Dude, what the heck? That sucks. That totally sucks, man. He made, and I quote, too much noise. Ah, of course. Yes, of course. Too much noise. Yeah, isn't like the lunk alarm a thing? It doesn't have like I'm pretty sure that it just doesn't function at the one that I go to. It literally just doesn't do anything, but I've never seen it go off, and the people there do not care. Not even a little bit. That's what they said you violated. You violated the lunk alarm. That is ridiculous, quite frankly. Okay, wait. This needs to be I plus equals 4. No. No, this needs to be I plus plus. Yes? Because this is per... Oh, okay. This is complicated. I think I am going to need another for loop, and this is going to be for... Yeah. I think that this is actually correct. I don't know, though. No, this isn't correct. Okay. This is gonna be I times 0, I think. Or I times 1? This needs to start at 1. Okay, this is so confusing. I really need to figure out how... Because I need to get each index. Let me look at my diagram. So this is 0, 0, 1, 2, 3. And then this is... Oh no. Ah, okay. Because for each of them with the vertices, if we go back to our previous diagram, we're adding 2 each time, unless there's one here. So if it's an edge, or if it's like a new part of an edge, then we're adding 2. Otherwise, we're only adding 1. Like, if I added another vertice right here, then I would actually be adding 3, but I would never do that because it's a rectangle. So if I need to add 1 here, I need to add 2 vertices. If I need to add 1 here, 1 vertice, 1 vertice, 1 vertice, 1 vertice. So maybe I need to actually just make all the vertices. So I need to go like I0, I1, I2, or it'd be like I0, I1, I2, I3, I4, I5, I6. Or this would be like index I0, and then this would be index I1, I equals 1, and then this would be the J. Create all of these. It needs to be width plus 1. So it just needs to be 0 to width. Yes. Yes, that is correct. I'm just gonna put all of these down here for a second. I need to deal with UV, I need to deal with triangles, but for right now we're just gonna do this. So I need the j component. Yeah. Hey Alex, how you doing? So this needs to be... This is actually going to be the opposite, where it's going to be y first. So this is going to be... Let's just zoom out. So this is index I, 0, right? And then this is j, 0. And then this is j1, j2, j3, and so on. Up until eventually we get to, like, the end of the array. Which would be... Oh wait, I don't have stream avatars activated? Good one. Oops. Wait. Oopsies. Thank you for pointing that out. Alex, you keep catching me lacking, alright? I appreciate it. So this is... the width. This literally is just until we get to the width. And the I is until we get to the height. And then eventually we get to the height. So for setting every vertice, I just need to do this, where this is I plus j, I think. Should be. Thank you. I'm glad you like it. I'm gonna be honest, I almost forgot to do it. I was like, oh yeah, I need to do that real quick, and I did it like 15 minutes before the stream. I was like, Alex is gonna yell at me if I don't. So don't worry, it's there. Don't worry about it. Okay, it's not I plus j, I don't think. I need to go back here. Where are you? No. Where? What? Why am I opening literally every single tab of the tab I want? So this is 1, 2, 3, and this would be 0, 1, 2, 3, 4, 5, 6, 7. This would be like 8, 9, 10, 11, 12. And this is... So let's just check it. Does this work? So it's I plus 1. So this is index 1. Okay. So index 0. 0 plus 0 is 0. 0 plus 1 is 1. 0 plus 2 is 2. 0 plus 2. 0 plus 3 is 3. Perfect. Okay. 1 plus 0 is 1. So it's not right. It actually needs to be 3 plus j, which is the width. So it needs to be I times dimension x. No, dimension x. Dimensions dot x. Perfect.
Computer Pigeon the King redeemed forced exercise. Backwards push-up.
What in the world is a backwards push-up? Also, welcome, Computer Pigeon. It's been a little while. Backwards push-up. What in the world? Backwards push-up? Okay, let's see. I don't even... Is it a reverse push-up? Is that what you mean? What is a backwards push-up?
The three important parts are your thoracic spine, your scapula, and this muscle called the
Okay.
shoulder. You're gonna get on your back, and then you're gonna bring your arms up,
Okay.
and you're gonna put them about the level of the
Reverse.
top of your
Okay,
head.
okay.
You want to make sure that those elbows don't open up, that they stay pointing
Okay.
face forward, just like so. From this position, all you're gonna do is keep your core nice and tight, and then push straight
Okay,
back
core
into
tight,
the ground.
then push into
2
the
to 3
ground.
second hold, and then come back down.
Okay, how does this guy do it? Is it the same? No. This is completely different. Which one? There's also the back bridge push-up.
Back to the straight. 2, flat on the ground. Now you might extend if you can get your arms all the way straight. And then keep pushing until you're at your absolute range. And you'll find.
Okay, I'm gonna try to do this. If I can do that, I'm gonna try to do this. Okay, let's get the exercise cam going. I need to adjust my camera real quick so you guys can actually see the exercise cam. Okay, wait. One moment. Let's enable this. Exercise cam. Okay, so. So it was like this for that guy. 1, 2, 3. 1, 2, 3. And then the back bridge one was 1, 2, 3. Oh, dude, that is really hard. Okay. 4, 5, 6, 7, 8, 9. Oh man. Okay, one more. 10. Oh. Oh. I felt that everywhere. Oh man. That was a good workout, thank you. Whew. Damn. I kind of didn't expect to be able to do that, to be honest. Goodness gracious. Alright, back to it. Whew. But how's everything been going with you? You have any fun work you want to show off? Anything at all? Oh. Yeah, I feel like every single vertex in my spine popped. You got a forge? Like, for blacksmithing? That's awesome. Wait, do you have pictures? Dude, I want to build a forge. I want to so bad. But I don't have the place to put it. Which is honestly the main problem. Like, you can make one pretty cheap. Relatively cheap. But I don't have a place to put it, man. Maybe someday. Soon, TM. Okay, this needs to be J I yes. And we can do the same thing with the UV. Okay. Wait, what? Okay, interesting. Interesting. You have a gas forge because of space limitations? Yeah, I feel like if I were to get one, I'd probably get a propane forge. Those seem like the easiest. Ooh. Okay, how... Because I need to set the UV coordinates. I could just set them to 0, 0. That would be fine. For our purposes at the very least, but I would... It's suboptimal. I just need to change this to where it's once again none, and then it'll be fine. And now I need to set the triangles. This is the hardest bit. Because we have all the vertices. Because this is setting all the vertices and the UVs. We put a pic in the Discord. Ooh. Nice. That's awesome, man. You're making Yale hook. One of those things that blacksmiths always recommend. Make like 1,000 hooks. Make 1,000 little leaves. Have like a bread and butter project that you can just make 1,000 of to actually learn how to use the hammer and the tools properly. I don't know if anyone ever actually makes 1,000 of those, but I know it's been suggested many times. Okay, how... Huh. Because this is... Yeah, let me make another diagram. I'm a lover of diagrams, apparently. I'll use this one. So this is 0, 1, 2, 3, 4, 5. You got a Napsta book lamp from Fangamer. What is a Napsta book? Or Nabsta Blook? Oh! Neat. You've one of a knife? Send it in. I know Nabsta Blue. It's a little ghost. Eight, 9, 10, 11. 12, 13, 14, 15, 16, 17. Okay. Because, yeah, this is 6 vertices, but it's actually 5. So this one is 0 to 6 to 7, and then 0 to 7 to 1. Which is... So let's say that this is index 1, this is 1, 1, 2, 3, 4, 5. And these are the quad indexes. Why'd she send it in? You DM me your Napster Luke. Look at it. That's adorable. It looks very bright though. It is very cute. I like that. Dude, Fangamer has a lot of good stuff. Wait, then you send in the knife? Whoa. Nice. How long have you been doing it? Dude, it's such hard work. I've only got to blacksmith a couple times. It is really hard work. You have to be really strong to do it for a while. And the endurance, oh goodness. So this is 1, 2, come on, 2, 3, 4, 5, 6, wait, 1, 2, 3, 4, 5. Okay, I guess this would, yeah, this is a 6x5.
Alex or something
Ah.
1234 redeemed suggest a song.
Protocol, Undertale Yellow.
Protocol, Undertale Yellow.
Okay. Protocol, Undertale Yellow it is. Protocol, Undertale Yellow. I'm thinking about moving my mic to, like, the center right here, like Thor does, because when I get really close to the mic, the quality goes up a lot for some reason. Because this mic is very sensitive. Okay, Protocol. There we go. I can never click on the right tab, goodness. You can do it for around 4 hours before you need a break. Dude, that is bonkers. I couldn't do it more than, like I could do it the whole time, because there's a lot of... You have to put it in the forge, wait for it to heat up, and you're kind of just sitting around. And that's kind of a break, a lot of the time. Unless you're going really, really hard at it, to where a lot of people that are really good at blacksmithing, they'll just turn the forge, like, way up, and they'll just put it in there for a few seconds, you take it out, and then you just hammer it a few times, and you're constantly moving. It's a non-genocide version of apprehension? Okay. Okay. You have 3 projects in the forge at a time to conserve fuel? Oh, then you are going constantly. You're a madman. What? Dude, you have... That's a bonkers amount of endurance. Damn, dude. Okay, so... For these quads, it is like 0, 6, 7, and then 1, 7, or 0, 7, 1 for the first quad. You have endurance in one arm? My right arm is stronger than my left. I mean, hey, that's all you need, man. Okay, so this is a width of 3. So the width is 3. And then... Let's make the height 2. So it's a height of 2. You've been playing Earthbound? You know, it's the game that started so many other RPGs that inspired a lot of people. I have played a very little bit of Earthbound. And I didn't care for it, honestly. I haven't gotten that far. Yeah, like Undertale. So this is 1, 2, or this is 0. the fuel's far more expensive than the steel. You can get a lot of scrap steel or scrap metal. It works all the same. Okay. 6, 7. So the first triangle is always going to be 0, index 0, and then 1 plus whatever I is, and then 2 plus whatever I is. The second triangle is always going to be 0, 1, and then I plus 2, or I plus 1, J plus 2. So it's J yes. This is so confusing. Okay, so it's J. These are the variable names for the for loops. So 0 is J. I'm just gonna put this in comma, so it'd be 0, 1, 2, and then that's gonna be J, I, so it's I, so it'll just be, yeah, 0, J plus 1, and then I plus 1. Moving up there. Which, we're already kind of doing that here, to where this is I times the width plus J. Okay. So it's I times the width plus J. So this is 3. I'm doing 0. 0 is... That's the 0th index. Always. T0 is always going to be 0. T1 is always going to equal the current I. It's going to be 0 plus 1. No. It's going to be width. This is so confusing. It's going to be the width plus 1. Yes. Width plus 1. T2 is always going to equal the width plus 2. T3 is always going to be, right, because we're setting, yeah, 3. 0, 1, 2, and 3. This is the 31st song in the OST, and the final boss theme for only the second area. Yeah, I know, dude, Undertale Yellow has a lot of songs. I feel like I've listened to quite a bit of the soundtrack now because of you. Which I'm not complaining, I love the soundtrack. It's a banger. Absolute banger. Okay. So... T equals 0, and then 3, that's going to be, again, 0. And then it's going to be T4, it's going to equal W plus 2. I'm trying to just do all of the, like, assignment manually in my head, which is what I'm doing right here. And then I'm going to try to extrapolate some kind of formula to put into code. Because I need a generalized formula for this. There has to be a pattern somewhere. So T5, which 1, 2, 3, or 0, 1, 2, 3, 4, 5, that's just going to be 1. Yeah, 1. Cool. And now, what about T6, which is the start of the next one? So T6, which is the 6th index in the array of the triangle array, that's going to be 1. T7. That's going to be T7 is going to be up here. So that's just going to be W plus 2. Yes, W plus 2. T8 is going to equal W plus 3. T9 is going to equal... It's going to be down here. That's going to be 1 again. So T0 and T3, T6 and T1 equal each other. That makes sense. And then T2 and T4 are the same, which means that T10 should also be the same as T8, which, let's see, 6, 7, 8, 9, 10. That holds true. So that should be W plus 3. And now T11 should be 2. So every single... Okay, I'm just gonna do this again. I'm pretty sure that I see the pattern, but we only have a sample size of 2. So let's just do this again and see if the pattern holds. And then we can try to solve this formula through induction if we really want to. But I think that we don't need to. We can just manually test it. We don't need a rigorous mathematical proof for this. If it sounds like I'm speaking nerd shit, it's because I'm speaking nerd shit. So don't worry about it. So this is T11, index 11. Or, yeah, sorry, T12. Which is going to be 2. And by the way, the reason I'm making these distinct is this is the first quad, this is the second quad, and this is the third quad. And then this is the first triangle. This is the second triangle. So for all of these, it has 2 triangles because it's a quad. So think about a triangle, or think about just a box, right? The way that games are rendered is using tris and quads. So it's actually only usually done using tris. So how do you split a box up into 2 triangles? Put a line through it. So for this triangle, which I'm going to call triangle A, that's going to have this vertice, and this vertice, because you need 3 points to make a triangle, right? So just think of a vertice as a point in space. Okay, perfect. So this is going to be A1, the first vertice, A2, the second vertice, and A3. So this is the third vertice for this triangle. What about B? Well, it's actually going to share this vertice. It's going to share A1. That's actually also going to be B1. And then A3, it needs... The B triangle also needs that one. So that's actually also B2. And then this isn't shared. This is a B exclusive one, and this is B3. So this, again, holds true to where A1 and B1, which is T0 here, and T3 here, T6 here, and T9 here, these equal each other. And the same is true for A3 and B2, or T2, T4, T8, and T10. This is always going to be true. So that is the visual proof for what I'm doing. We're not going to make a mathematically rigorous proof because discrete mathematics scares me, and I don't want to do it right now. Induction is hard. So this should be W plus 3, right? I'm not even going to look at the triangle and do it manually. I'm actually just going to follow the pattern and then hope that this works. So this should be W plus 4. This should be 2. T15 should equal 2. T16 should equal... And again, we have 0, 1, 2, 3... Okay, yeah. So T16 should equal something. T16 should equal W plus 3. No. Is this right? Wait, T10? Yeah, that's right. So it should equal W plus 4. Holding to our pattern. Presuming it does hold to our pattern. This is actually proof by induction, by the way. Well, technically not. Usually you do it to, like, some arbitrary value, and then you check that it works at some arbitrary value plus 1. But, doesn't matter. And then this should be 3. So let's check this. So the third quad, which is going to be this one right here. The first vertice should be 2 for this triangle. For triangle A here. Remember, think of this diagram. So triangle A. That should be 2, 6, and 7. Let's check. So 2. Good. 13, it should be 6, which is W, which is 3. Plus 3, so that's 6. And then W is 3, so that should be 7. It is 7. Because again, think of A1, A2, A3. That forms that triangle. I accidentally got rid of this. Oops. Okay. And then let's look at this. The first one in triangle B, which again, just think, move this quad right here. That's all I'm doing. So for triangle B, it should be... I'm actually just going to mark A... B... It should be 2, it is, perfect, and then it should be 7, which is W plus 4, and then it should be 3, which it is. Okay, so this pattern does work. We know that. Now we just need to make it work in code. And this is only for one dimension, so let's go up again. And this is going to be 8, 9, 10, 11. So, presuming that, let's say that this is I, right? So if we're doing it in a for loop, then we have two variables, I and j. This is a lot of numbers, so here's what I'm doing, Crazy Mike. So currently we have... Okay, it doesn't work. That's because what we had... Let me just create this. We had a plane. Crazy stuff, right? A singular plane. Set this 0, 0, 0. Perfect. Where's my plane? Wait. That's why it's not working. Let me create an empty game object. Add a mesh filter. Add a mesh renderer. Give me a moment. We need to give it the plane. Give it the correct material. It's rotated incorrectly. Nope. 90. Okay, I don't care to explain. I'm just gonna wait. We're making quads. That's what we're doing. It doesn't work. Whatever. It does, I swear. I promise. There's a plane. We're making quads. What I'm trying to do is I'm trying to make a grid of quads. Like this. Where it's just a bunch of boxes. Right? With two triangles. This is triangle A, this is triangle B. Each quad has one of these. In order to do meshes in Unity, you need to first create the mesh, and then set the vertices, the UV, and the triangles. So, what we're doing, or what I'm trying to figure out, is how to do that at any... excuse me. If, let's say that I want it to be 4 quads wide and 6 quads tall, then I'm trying to figure out how to do that for anything. Yeah. The reason I'm doing this is so that I can basically have a metal bar, and then whenever you hit or click on this piece of the metal bar, then this part is going to bulge out. I want it to be like real-life blacksmithing, to where you have to like draw out the blade, so you would hit a bunch of different times, and then it would move the material in the opposite direction of where you hit, which would be moving vertices farther out. Which is hard to do. So here we are. Okay. Also, how's your... Are you done with the Plants vs. Zombies area? Or the... It's basically Plants vs. Zombies. You know what I'm talking about. Because your game's releasing really soon, right? Like, you wanted to release it in March, I think? Okay, so... If we move up here, then our starting is going to be... Presuming that this is like... Let's say that this is I, and this is J. So this is the I index, and this is the J index. Or axis, sorry. So this would be I0, J1. This would be I0, J... Or J0. I0, J0, I0, J1, I0, J2, I0, J3. And this would be I1, J1, or J0. So it'd be 0, 1, or 0, 0. No, 1, 0, sorry. 1, 0, 1, 1, 1, 2, 1, 3. And then... That would be for these... Oh, I'm not explaining this properly. That's okay. We'll live. We'll survive. So this is 0, 1, 2. Let me just mark this out. Horribly jank. There we go. Great axis. This is a matrix. Love it. I think. This might be a matrix. I might be gaslighting myself. 0, 1, 2, 3, 4, 5, 6, 7. Okay. So what is this equal? This is double of this. No, it's not. This is this value right here. It's 0, 4, 8. And then this is 1, 5, 9. 2, 6, 10. So it's incrementing by 4, which is W plus 1. This is W. This is the width. This is the height. So this is plus 1. So this is W, or this is J times W plus 1. This is J times W. No, this is... I'm losing it. Let's look at this one, okay? 1 plus 4 equals 5. This is I1, J1. This index right here. I1, J1. This can also be written as 3 plus 1. Because this is the width. Width equals 3. That equals 5, which is this index. I love one-dimensional array math. Love it. I love dealing with flattened arrays. Yes! Okay. So, 1 plus 1 plus 3, which is just the width. So it's 1 plus width, which is... This is J. No, this is J. Because this is... Let's look at 5, or 9. This is 1 plus, which the 1 is the J. So really, it's J plus... It's not 1 plus 3. It would be 1 plus 7, which is actually I1 plus width. That is what this equals at any value. So it should be, 11 should be... So just look, we have the value for width, so 1 plus 3. And then, let's just say at index J, and we know that this equals 11. What is I? Let's look at I. It's 2. So this is going to be 4 times 2. J should equal 3, which it does. So this is correct. It should be. Someone who does pixel art, you have no idea what this is? This is a lot of mathematics. This is why we take college. We take a lot of math as a computer science major. A lot of math. Do you want to know why? Because I couldn't do this if I didn't understand fundamentally how these things worked. This is kind of discrete mathematics. This is kind of a discrete mathematics problems. You skipped linear. Okay, every every programming major skips linear, which is bad. Linear algebra is incredibly important for a whole host of reasons. Everything in math that you deal with for computers feels like it comes down to calculus, discrete mathematics, and linear algebra. These three are like the pillars. You looked at an ML class and you were screwed. Discrete is huge. Discrete is the biggest one. Yeah, discrete is super big. I'm actually currently in discrete mathematics. I really like the course. It's very fun. Because it feels like it's just a programming problem. It's just logic problems like this. This could be a discrete mathematics problem. So yeah, this is the formula for the index of what this needs to be, and then we need to solve... So we have it for I and J now. That's good. Now we just need to figure out how to do this. Because we have this. We have the loop for I and J. which J is the X dimension, I is the Y dimension in the grid. Okay. And I'm setting this to that index. Okay. So this is really T0 equals I. And this is for any triangle. I'm just going to do 1 through 5. Or 0 through 5. This is for any quad. So for any quad, T0 equals I... No, this equals... the width plus 0. No, wait, we need to find the starting point. Because this is J. This is literally just the J value. This is just J. This is just J. This is just J, because that's on the first bottom one. This is when I equals 0. I need to do the second dimension. Okay. Or not the second dimension. We're gonna ignore this for a second. We're not gonna do it in a quad, because I want to be able to verify this. So we need to just do the second layer of quads. So we're gonna do another layer here. This is going to be a... Actually, I'll just write it out first. Can I move this? I don't think I can. Wait, sorry, one moment. Alright, sorry about that. Discrete mathematics, my beloved. Okay, let's keep solving this, and then we'll try to find... Sorry, my family's screaming. Sorry about that. Okay. There has to be a tool to actually move this. There's no way they wouldn't add that. Right? No way. No way. Okay, yeah, this, I want all that. Editing is a paid feature. Thanks, man. Awesome. Okay. We'll just ignore that. So this is 1, and then I'm going to have 2 over here. And then we need, again, the first quad, the second quad, and the third quad. So, first quad, that's going to be T17, or T18, sorry. T18 is going to equal 4. Which is double this value. T19 is going to equal... I'm curious. No, let me change the size, thank you. Let me move this. Thank you. Okay. If I set this to an arbitrary... Okay, whatever. Arbitrary T, I should be able to find this, or an arbitrary index. I will be able to find it, but let me just do this, again, manually. But I'm pretty sure this is going to be double this, which I can try to verify that real quick. So that would be T1 is W plus 1, which is... Yes, so W plus 1. This T1 is going to be 2 times W plus 1. It's going to be this. I'm pretty sure. So this is... It's going to be 8. Which is 2 times W. Or, yeah, so it would be J, which is 0, plus W, or times I, which is 2, times W, which is 3, plus 1, which this all equals... And is that true for this? Let's do the math. That's 0 plus 1 times... Whoop, come on. 0 times 1 W plus 1, because this is in the first index of I, and that's going to equal 3, because W equals 3. So it's going to equal 4. So yeah, that's right. So for any index, or for any value given the index, we can find that. Now, can we find the value of t given the index? Because that's what we have. We have the index, and we know how to find... So we just need to find the value t for everything. Okay, we can do that. So we know that t of something equals j plus I times 1 plus W, which is j is the x index, I is the y index, and then W is the width. So how can we get from this? Let's do another one. Let's just real quick. Let's do the rest of the triangle, or the rest of the quad even. T20, that equals 1 plus 2 times 3 plus 1, which equals 9. This equals 8. Let's check if this is right. So it should be 4, 8, 9. For this one right here. 4, 8, 9. That's right. Let's do the second triangle. So this is going to be T21. This is the second triangle for this quad. This is going to be T22. This is going to be T23. Ah! Stretch! Meh! Alright. So T21 is going to equal this. So it is again going to be... It's just going to equal T18. Which is going to equal 4. This is going to equal T... Yes, it's going to equal T14. Not T14. T19, correct? No. T20. T20, which is going to equal 9. Which, if we look through the entire pattern, this always holds true. Because again, if we look at the triangle, A1 and B1 are the same, and A3 and B2 are the same. Which is why we have an odd offset for this, to where it's 3 off, that is the A3 and B2. And we have an even offset for this one, which that's the A1 and B1. Which it's an offset of exactly W plus 1. It's all coming together. That's what I love about math. I might have been literally doing computations for the past hour and a half, but now it's coming together, okay? Computations and problem solving. I have all of these notes, all of these glorious notes. And they'll let me do what I need. And now this, T23, which is going to be a triangle using 4, 9, and it should be 5. Which is T21 plus 1. Which is going to equal 4 plus 1. Which is going to equal 5. Does that always hold true? Yes, literally always. Wait, we can find, given just the first value, the rest of them. This is always, I think, wait. W plus 3. Is this right? Wait. No, that's not right. Ugh, shucks. Wait, this is the third quad. So T13, that's 1, 2, 3, 4, 5, 6, 7, 8. Oh, wait, 1, 2, 3, 4, 5, 6, 7. Where am I? So 1, 2, 3. 0, 1, 2. That was my problem. 0, 1, 2. 3, 4, 5. Okay, wait. I just noticed another pattern. These are the same, so T1. So if we find the first triangle, or the first quad, every 6th index, which is H times W, every H times W index. No, wait, that's just not correct. It's H times W times I. H times W times I. So at 0, it's 0. At I equals 1, it's 6. Is the first starting index. At I equals 2... Shucks, it's not I, it's J. No. It wouldn't be J either. Why does this have to be so complicated? This is a very difficult problem to solve. I can do it, though. I can do it. I can do it. And then I'm gonna come to my discrete math professor with all of my notes, and he's gonna be like, you know, you really could have just done it this way, and then I'm gonna cry. I'm gonna sit there and cry in my seat. My discrete math professor's a really cool dude, though. I'm the only person who shows up to the office hours, so we basically just nerd out about math for like 2 hours. And then sometimes get some work done. But I feel like if I brought him this absolute catastrophe of notes, he would be like, you know, don't ever do this again. Do it this way. And I'll be like, thank you. So it's 0, 4, 8, which is... Oh, it's because we're adding 2 each time, so it's... The index... This is so... Okay. I can do this. I can do this. I can do this. If I just keep telling myself I can do this, it'll become the truth. I need to actually solve these. Because this is confusing me. So let's properly solve all of these using the formulas that we've already derived. And then... Okay. So what should T1 be given this formula? Because this is... T1 is... Well, it's not even using the formula. It's 4. Okay, I know it's 4. Because it's W plus 1, right? Yes, I can't okay, I can't... Ugh. Yeah, so W plus 1 is 4. W plus 2 is 5. W plus 2 is 5. Which we don't even need to do that calculation. We already know it's true. Because if we go back 2 for each one, then it's correct. Should be for no matter what. Doesn't matter the index, doesn't matter the I, doesn't matter the J, doesn't matter the width, doesn't matter the height. This is always true. So it will be 5. Nope, don't need the brushes. Yeah, math professors are super chill. I feel like most professors are actually just really chill. If you just like go in and have a conversation with them. That's one thing that I think was like the biggest jump from high school to college for me. I didn't really know any of my high school teachers. I'm kind of friends with a lot of my professors. Like, obviously there is a very clear hierarchy there, but like, we just talk. We just hang out. Now, it's about the subject, but like, we get along and like it. And once I'm out of college, I would like to continue to talk to these people, because I just like interacting with them. So this was W plus 2, which is just this plus 1. So this would be 5. And then this would be 6. And then this is 6. And this is 6. And then this is 7. And this is 7. So... Okay. This should hold to our formula. Let's try to get T4, which is at I index 1, 1. So that would be 1 plus 1 times 1 plus 3, which is going to equal 1 plus 4, which is going to equal 5. What did we have here? We had 5, T4, 5. So the only values we actually need are the T0, the T4, and the T5. But really we only, or the T0, T1, and T2. But T2 just equals T1. Okay, so from T0, we know the value of T3. From T1, we know the value of T4 and T2. And actually, from the value of T0, we know the value of T5, because T5... Well, it really only equals... like, that just equals t0 plus 1, right? Which that just equals 0 plus 1, which just equals 1. And if we look at this, this is just one more. This is just one more. One more. And that should hold true forever. I mean, like, I can make a mathematically rigorous proof, but it's not gonna change that fact. So we only ever need T0 and T1, because from T1 we can find out T2, it's just T1 plus 1, and then from T2 we can find out T4, and then from T5 we don't need that. We only need these two. We only need the first two. Which is the index of I at 0, then it's 1, and then it's 2. No. Maybe? I think, possibly. It's currently the index of I, but here... it stops being the index of I. Instead, it still holds to this. And the reason that it's the index of I here is because I equals 0. So it's actually the index of j. There's no quad here, so we're not starting here. So it's the width minus 1 is the max. Okay. Cool. I'll be right back. I need to get some water. And to run to the bathroom to take a piss. What are you looking at? Okay, wait. I'll explain this real quick. So, this is my math. Why am I doing the math, you might be asking? I'm trying to find out a way to make a grid of quads. A quad is made up of two triangles. Triangle A and Triangle B. Triangle A is made up of 3 vertices. 1, 2, 3. Which I affectionately am naming A1, A2, and A3. The second triangle, Triangle B, is also made up of 3 vertices. But with these, their hypotenuse is touching, right? That's what this is. That's the hypotenuse. So these two are actually being shared, so we only ever need to add 1 vertice. So this is B1, going clockwise again. B1, this is B2, and this is B3. And if we look at this diagram, because the hypotenuse are touching, we're sharing these vertices. We're sharing A1 and B1, and then we're sharing this vertice in the top right with A3 and B2. So what this is, for given a height of 2 and a width of 3, which is 1, 2, 3 quads, and then 1, 2 quads, I'm trying to find the values that I need for the triangles, because each... So how the way that triangles work in Unity, there's an index in a array of triangles. We already found out the length of that array, or the size of that array, but we're trying to currently figure out, given the index of that array, what is the corresponding vertice index? Because we're setting all of the vertice indices here. We're setting all of these vertice indices to a position, to the correct position on the grid. You're gonna go back to your basic 2D Godot work? Good luck. Alright. Oh man. Okay. I'm gonna take a quick breather here. I'll be back in... I'm gonna give myself a timer of 4 minutes. I'll be back in 4 minutes, alright? And we'll keep working at this. Whoop. Okay, there we go. Timer started. Okay, I'm back. Stop the timer, go back to the main scene. Alright, welcome back to Math Hell. I love mathematics. Okay, so we only ever need to find T1 and the T0. Because again, so given T1 and T0, we know that T2 is going to be T1 plus 1. we know that T3... So I'm going to instead, at any nt, alright? So at Tn, so Tn is given. So we know this value. We also know Tn plus 1, right? So at n plus 2, presuming that n is the start of one of these, which n is quad start. Then we know that n plus 2 is going to be, or t at n plus 2 is going to be t at n plus 1 plus 1. And we know that t at n plus 2, or n plus 3, sorry, which this is the first triangle, this is A, this is B. We know that t at n plus 3 is always going to equal t at n. We know that t at n plus 4 is always going to equal t at n plus 2. And we know that t of n plus 5 is always going to equal t of n, or t at n, sorry, plus 1. So, once again, all we need to find is t of n and t of n plus 1. I don't know how to do that. So we're gonna... How do we do that? Huh, okay. So simple, yet so incredibly complicated. So this, again, is just moving up 1 in the y for t1. We're just moving up 1 in the I index. So... this equals w plus 1. This equals w plus 1 plus t... Okay, wait. I just realized something. Okay, wait. We're gonna make another inference here. This is this, or this value right here is whatever it was previously plus 1, right? It's also whatever the first one was plus this every time. So we actually only need to get w plus 1, which this is just going to be w plus 1, and then add t of n to it. So it's t of n plus 1 is actually just t of n plus the width plus 1. So we only ever need to find T of n? If we find T of n, we can find everything else. And T of n, it equals 0, 1, 2, and then it would equal 5, 6, 7. Okay, so interesting. It always skips the width. It always skips the width. Hi, welcome back. Welcome to your homebrew discrete mathematics course. I am trying to solve a very complicated problem in a very inefficient way. And we're here. We're doing it. I feel like I can solve this problem and implement it before I end stream at 4 p.m. That is my goal. I may be a fool. I've been doing this for 2 hours already. So we're gonna figure it out, and it'll be okay. I got 50 minutes. Gotta hone in, alright? Oh, gotta pop my knuckles. Gotta stretch. We're in math mode, alright? So we found out through all of this math, given T of n, if n is the start of a quad, which means if n is this right here, or this right here, or this right here, this is the first quad, this is the start of the second quad, the start of the third quad, the start of the fourth quad, the start of the fifth quad, the start of the sixth quad, the start of the seventh quad, the start of the eighth quad, the start of the ninth quad. So it always skips whatever width is. Because it's 0, then 1, then 2. Skips over 3 because that's the end. There's no other quad to start. And then goes straight to 4. So if j equals 3, then we just don't do anything with that. Or really, not if j is equal to 3. If j divided by the width equals 0. Or if that divides evenly, sorry. If it is a real number. So if j modulo w equals 0, then we just don't do any of this. So we never need to go this far. We only need to do this while j is less than 3. And then we go up. And then we add 1. Which this is 1, so it's... How would I figure this out? 0, 1, 2, 3, 4, 5. So this is 0 through 5, this is 0 through 3, this is 4, this is 6, so it's plus 1, so this is the width. The width here is 1, 2, 3, 4, 5, so this is 5. The width is 5. The width is 5. This is... Let's just presume that it is a height of 2. We know that it's 6 here, and it's... So it would always start at 0, 1... Oh, I'm still listening to Protocol? Dude, I've just been jamming, okay? You don't even know. I've been gaming. Alright? Just jamming out to it. Okay, so it would start at 0, 1, 2, 3, 4, 6, 7, 8, 9, 10, 12, 13, 14, 15, 16. So it always skips this. Okay, so it's not J plus... Oh no. Oh no. It's not if J that modulo. That would be this number. Correct? Yeah. Oh goodness. Okay. Okay. We're just going to ignore the code. The code doesn't matter. I'm just doing math. Alright, we're a math major for the next hopefully 30 minutes so I can actually implement this in code. So it's J plus I, right? Because this would be 3 plus 1. No. It's actually... Well, I'm going to blow your minds here, okay? Probably not, but just bear with me. J times I, which would be 0 times 3 modulo 0. What the hell am I saying? No. No, this doesn't work. Damn it! Damn it, damn it, damn it. Mathematics, man. I'm this close to becoming a math major, alright? I'll break someday. All of my math professors are actually trying to break me, though. My history math professor, on the first day of class, we walk in. He said, I'm only teaching this course so that I can trick as many of you as possible into taking my other course. And I was like, I respect that you just went out and said it, but then he proceeded to, every single time someone had a very interesting question, say, you know, you'll learn about it in 306. Which 306 is the math course that he teaches. It's advanced discrete mathematics. Bastard, okay? That's messed up. Because it's all cool stuff. And now I want to take that course. But I can't. I can't do it. It would mess with my whole schedule. Although I still might. I might do it. I might just take out an extra class. It's a banger. It's teaching, like, graph theory and stuff. Which is insane. And I'm stalling. I need to get back to work. Okay, fine. Yes. Okay. So... This is how to make a programmer cry in 3 steps. Step 1, give them a problem they think they can solve. Step 2, have them do math for 4 hours. Step 3, there is no step 3, they're already crying. Okay, wait. How do I figure out if it's a start? It's always this number. But why? Why is it this number? Is that width times 2? Oh my god, is it always width times 2? Wait. I need to do the math here. So this would be... 1, 2... It's always 6. You always increment it by 6. Doi. Of course you increment it by 6. Doi. It takes 6 vertices. Because it's 2 triangles, which each have 3. What's 3 times 2, Ethan? What is it? It's 6. I sat here staring at my screen for all of 15 minutes trying to figure out how many vertices were in 2 triangles. It's 4. It's 4 vertices if it's a quad, but you actually need to assign it for 2 triangles, so it's 6. How did I'm kind of angry at myself. Not even kind of, I am viscerally angry with myself. Damn it, man. Okay. We figured it out. I can't believe it took so long to figure it out. So, at the starting index of this is 6 times width, which is 6 times 3, which is 18. That's the starting index for the next one. So, yeah, okay. I feel like a fool, I'm gonna be honest. So in a loop, how are we gonna figure this out? This is the first quad. At j equals 0, I equals 0, j equals 0. This is the second quad at I equals 0, j equals 1. This is 0, 2. And this is 0, 3. But at 0, 3, we don't want to do that. Okay. But the starting is always... Oh, I'm so silly! That's not what I was trying to find at all. I'm trying to find the value of it, not the index of it. The index will always be 6... We'll figure that out later. It's not important. Yeah, 6 times the quad that we're doing. So this is the third quad. So it's going to be 6 times 2, because this is this is the 0, this is the 6, this is the 12. So it's whatever quad we're doing. So the index is t, whatever quad we're doing, the number of quads, whatever quad number we're on, minus 1 times 6. And now, we have to figure out this value. This value is 1, 0, 1, 2. It skips over 3. And then it is 0. And then it is this plus 4, this plus 4, this plus 4, this plus 4. But we want to skip over that. So this is... What is 3? Is this 3 mod? So this is 3 mod 3. Which I'm just gonna do the percent sign. That always equals 0, obviously. This is gonna equal 1. 7 mod 3. And mod just means the remainder. If you do... like 3 divided by 3, there is no remainder. 7 divided by 3, there is a remainder of 1. 11 divided by 3. What's the remainder? Well, we can do... it's 2. Because it would come out to 9, which is 3. It's 3... and then... yeah. And then we'd have a remainder of 2. Because 11 minus 9 equals 2. Perfect. So that means that if we added another one here... which, let's just do that for posterity's sake or something. This is 12. This is 13. Let's just try to figure out, what should this be? This should be mod 3. It should be, whatever it is, mod 3. Which is just 0. It should just be 0 again. 14. 15 is divisible by 3 evenly, so it is 0. What is 15 mod 3? 0. It is always 0. So it just goes 0, 1, 2, 0, 1, 2, 0, 1, 2. Forever. Awesome. So I know that pattern. How can I implement that? Because it would be 0, 1, 2, 0, 1, 2. Okay. N mod 6 equals 0. It must equal 0 in order for this to work. Otherwise, it is not, it can't work. Okay. Okay, so T goes 0, 1, 2, 4, 5, 6, 8, 9, 10. Hum. So again, whatever the width is, wait. Oh my goodness, I just realized how to this is mod 0, the I index is 0. This is mod 1, the I index is 1. If this is mod 2, the I index is 2. Does that hold true for anything else? This would be mod 1, this would be mod 2, this would be mod 3. So it will only happen for boop. So it'd be this and this, this and this, this. No. This and no, wait. It's always going to be the first. Oh, okay. Interesting. Because this would be index 3, which is 0, because the I index. So T of n. Oh, okay. That's going to equal something. Oh, okay. Also, this is incorrect now. Because the new height is 3. Stop doing the brushes. I don't care. Okay. There we go. The new height is 3. So it's 3 by 3. So, if n is evenly divisible by 6, then it is the start of a quad. If it's evenly divisible by 3, it's the start of a triangle. Cool. That's neat information. N plus 3 is always going to have a 3. This is always going to have n plus 1 mod 6 is always going to be 1. Alright, cool. Alright. T of n is going to... Okay. So I need to skip over this index if it is not equal. So if the index, which I'm just going to call the point, I'm just going to call it P, alright? So this is P0. This would be P1. Alright, that we're just gonna... Are we cool with that? Perfect. So P0... This is mod... So, this would be... If... He... mod... W plus 1. If that equals 0, then fine. What does that equal here, though? That's gonna be 3, that's gonna be 3, that's gonna be 3, that's gonna be 3. Oh, I just figured it out. Okay, so we just need to take the first point. Which is index 0. Oh no. Wait. Oh, I'm so silly. I just figured out a way to do this. Specifically this part. So, our starting index is always 0, right? And then this is just W plus 1 times I. Because it's J0. Oh my goodness, my arm. And this holds true to this function that we found. So this is just 1 plus W. Always. The first index of a row is going to be whatever the I value is, whatever the Y value is, times W plus 1. Meaning that we just need to find I, which we already have. So we just need to not do it if this equals okay, wait. Bear with me. So it's going to be our formula for whatever this equals, right? So it's going to be J plus I times 1 plus W, right? That's the formula we derived up there. If that mod W plus 1 which let's look at this. This is going to be 0. Okay, let's look at j plus I modulo w plus 1. One plus w. So let's just assume real quick. 0, 0. What is this going to be? That's going to be 0 mod 4 is always going to be 0. So that's going to be 0. What about this? That's going to be 1. That's going to be 2. That's going to be 3. Which is equal to the width. This is also going to be 3. This is also going to be 3. This is going to be 0, 0, 0. 1, 2, 3. So if this equals the width, then we just don't do it. And we only start this. So if, I'm going to just write pseudocode here. 1, 2, 3. So I'm gonna do C#. Thank you. So if, moving this to my other monitor, j plus I mod w plus 1 equals w, then we want to call the set triangle, we want to set the triangles, right? And the value that we want to set it to is just going to be I w plus 1. So we want to do set, or yeah, set quad verts. We want to pass in this int. Which, in order to do that, really all we want is that's t1, right? So this would be t, which is triangles. What did I call this? Yeah, triangles. So let's set this value. This is going to be int n equals this. Alright. Triangles n equals wait. That's what this equals. N is going to equal because we know that this is true. No, stop it. Stop it. Alright, so we know that this is true. If that equals w, which we're doing right here, and then our n value is, again, just if it's divisible by 6, which we need an iterator, or not an iterator, rather, we need to know what the last index was. So outside of this, we're just going to have int triangle index. I'm not even going to set that. That's going to be set. And then we're going to set n to triangle index. And then we're going to set triangle index. Or wait, number of quads, or quad index. We're going to call it that. Then we're going to increment quad index. And this is going to be quad index times 6. Because remember, there's 6 vertices that we need, or 6 spots in the array that we need per quad. 2 triangles. And then we know, because all the math we did right here, we know that t n plus 1 equals t n plus w plus 1. And then we know that t n plus 2 equals t n plus 1 plus 1. We know that t, and this should be triangles, n plus 3, which this is first triangle, and this is the second. Second triangle. That equals t n triangles n plus 4 equals t n plus 2 and then triangles n plus 5 equals triangle, or yeah, this should all be triangles. Oops, that's okay. That equals triangles n plus 1. And W is really just dimensions.x. I'm going to set these all to T, and then I'll change it back when I actually copy this code into Unity. Okay. I'm doing it. I'm copying the code. No one panic. Okay, so quad index needs to be set out here to 0. W is really just dimensions.x. Int W, and then I'm going to rename this to dimensions.x. Okay, come on. Why? Why won't you let me? That's rude and unusual. Can I Control F replace? It's fine. Whatever. Probably change that in my pseudocode. And then this is just triangles. Okay. Yep. Wait. Tab. I'm hoping that IntelliSense just... Yeah, thank you. Yep. You're amazing. Thank you, IntelliSense. Right. Look at this. This should work. I really, really, really hope that this works. Because if it doesn't, I'm gonna be very sad.
Computer Pigeon the King Redeemed suggests a song. Ace Attorney, Pursuit Cornered.
Ace Attorney. Pursuit Cornered. Cornered. Wait. Pursuit Cornered. This is a perfect song for this. Thank you very much. Okay, turn it on a little bit. Okay. Moment of truth. Okay. It did not work. At all. Why not? What did I set the dimensions to? Okay. Let's do 3 by 3. Okay. It's out of bounds. So what's wrong? We gotta do a little bit of debugging. But I'm pretty sure that the math works out. Triangles N. Oh. Ooh, yeah, that's not good. Okay. I need to do another if statement here. So this is if I'm actually just going to do an int, and this is going to be array index. Yeah, wait. Index. And then instead of doing this, we're going to get rid of all of these and then just put index. If index is less than dimensions.x. No, wait. If it's less than that. Although realistically, I should just make an int triangle verts. And now just set that to triangle verts. Because that reads a lot easier. Triangle verts. But not index. Maybe... If index +6, or +5, that should fix the problem. It was having an out of bounds error. Okay, it no longer errors. It is setting the vertices. It's 3 by 3. It should be 16. I think that's right. Okay, that's not good. What? Must be a multiple of 3? Wait. I don't know why that's happening. I need this to actually be properly rendered on screen. Okay, wait. I think it's the UVs. I'm pretty sure that that's the problem. Because if I instead set the UVs properly here, they're like 0, 0, 1, 0, or 0, 1, sorry. And then 1, 1. No, wait. Oh my goodness. Okay. How... Okay. We need the 4 corners. So we need to go back to here. And then this would be 0, 1, 4, 5. Which is N plus whatever, wait. It just T1, I mean T0, T1, T4, and T5. So we're going to set the 4 UV indexes here. I'm pretty sure it's a UV problem. And again, we need T1, or we need T0, which is no, we need triangles, 0. And that's going to be 0, 0. And then triangles. Four. Okay, so that's going to be T1. Which is not 0, but N. And then N plus 1. N plus 1. And then we need... We just need these 4. No, wait, we need these 3, and then this one. Yes. So N plus 2, And then the last one, which is n plus 5. And that's going to be 0, 0. That's correct. One moment. Okay. I want to get this implemented. We got 4 minutes, but I'm probably going to go a little bit over time. So we got like 10, 12 minutes. Oh my goodness, my hair is driving me bonkers. Okay, there we go. So, n plus 1. What is n plus 1? N plus 1 is that. So that's 0, 1 on the UV coordinates. 0, 1. N plus 2 is 5, so that's 1, 1, and then this is 1, 0. They should be right. Okay, come on, man. Why does it only have 2 triangles? We're gonna print the index. One, two, three, 1, 0, 1, 2, 3, 4, 5. And we have 12 vertices. Okay, there's something deeply wrong here. Am I gonna go out of bounds if I do this? Probably. No. Okay, we still have 12 vertices. And we still have 2 triangles. Okay. Wait. If quad index... This is just wrong. This needs to be times 6. That's why we were having a problem. Okay. Alright, we have an out-of-bounds array where? Right here. For some reason. Okay. I don't know how. Because... Wait, no, this is fine. Should be. Why can't I just set all of the UVs to 0, 0? Okay, wait. I'm going to quickly comment out all of this. And we're just going to set a really basic mesh. What? Okay. We're just gonna create a real basic mesh. I need all these. Perfect. This is going to be... We're going to have 4 vertices. We're going to have 4 of these. Don't need this. This is going to be 6. And now I need to do all of this. We're going to first set the vertices. So 0 is going to equal vector 3. 0, 0. New vector 3. 1 is we're going to go clockwise, so it's going to be there, 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 there. That might be counterclockwise for you guys. So it's going to go up 1. And then it's going to go up 1, right 1, and then it's just going to go right 1. And then the triangles are going to get set to... This is 0, 1, 2. Okay. No. Step, step, step. Okay. This should be 0, 1, 2, 3. This should just be 0. This should be 1. This should be 2. That should be 3. Triangles, this is going to equal 0, 1, 2. This is going to equal 0, 3, 0, 2, 3. 0. Should, right? Wait, let's go to paint again. Zero, 1, 2, 3. This is going to be 0, 1, 2, and then 0, 2, 3. Okay. This should render something. If it doesn't, then there's more things broken than I thought there were. And it's not with my math. Unpause. Okay, oops. Okay. This is what I think I'm gonna do. I think I'm going to try to figure this out on my own, and then next stream, Sunday, I'll come back and I'll explain what I did, because I'm running out of time. So, thank you guys so much for watching. I appreciate all of you. I appreciate your support, and I hope you guys have a fantastic night. Anyway, bye! I'll try to explain what I do next time, and also send some messages in the chat, so you guys can, or into the Discord, so I can explain the methodology. Yeah, thank you very much for watching.